Space is a vast and mysterious place, full of wonder and incredible events. One of the most dramatic and awe-inspiring events is the death of a star, a cosmic explosion of unimaginable power, a supernova. These celestial fireworks mark the end of a star's life, but they also signal the birth of something new. Imagine a giant star, many times larger and hotter than our own sun, reaching the end of its life. It has burned through all its fuel, the nuclear reactions at its core sputtering out. For a brief moment there is silence, a pause before the storm. Then, in a blinding flash, the star explodes, releasing as much energy in an instant as our sun will in its entire lifetime. The shockwaves from this explosion ripple through space, carrying with them the building blocks of planets, stars, and even life itself. These remnants of a dead star seed the cosmos, contributing to the rich tapestry of elements that make up everything we see and touch. In the grand cosmic dance of creation and destruction, supernovae play a vital role, shaping the universe as we know it. So, what exactly is a supernova? Simply put, it's the explosive death of a star. But there's nothing simple about the physics involved. These events are some of the most powerful explosions in the universe, visible across vast cosmic distances. Supernovae occur in two main ways. The first type happens when a massive star, at least 8 times the mass of our sun, runs out of fuel. Without the outward pressure generated by nuclear fusion, the star's core collapses in on itself under the force of gravity. This collapse happens so rapidly that it generates a shock wave, blasting the star's outer layers into space. The second type of supernova occurs in binary star systems, where 2 stars orbit each other. One star, a white dwarf, pulls material from its companion star. This extra material causes the white dwarf to become unstable and eventually ignite in a runaway nuclear fusion reaction, leading to a spectacular explosion. Regardless of how they occur, supernovae are incredibly luminous, often outshining entire galaxies for a short period. They are also responsible for creating heavy elements such as gold, silver, and uranium, which are scattered into space, enriching the interstellar medium with the ingredients for future generations of stars and planets. To understand supernovae, we need to understand the life cycle of stars. Stars are born from collapsing clouds of gas and dust, known as nebulae. As gravity pulls this material together, it heats up, eventually reaching temperatures high enough to ignite nuclear fusion in the core. For most of their lives, stars exist in a state of equilibrium, with the outward pressure from nuclear fusion balancing the inward pull of gravity. This process, where hydrogen atoms fuse to form helium, releases enormous amounts of energy, powering the star and making it shine. However, this balance cannot last forever. Eventually the star will exhaust its supply of hydrogen fuel. What happens next depends on the star's mass. Smaller stars like our sun will expand into red giants, eventually shedding their outer layers to form planetary nebulae, leaving behind a dense core known as a white dwarf. Massive stars, on the other hand, have a more dramatic fate. When they run out of fuel, they can no longer support themselves against gravity. This leads to the core collapse and subsequent supernova explosion we discussed earlier. Supernovae are not just destructive events, they are also crucial for the evolution of the universe. As we've seen, these explosions disperse heavy elements into space, enriching the interstellar medium with the ingredients for planets, stars, and even life itself. Without supernovae, our own planet and everything on it, including us, would not exist. Furthermore, supernovae play a vital role in regulating star formation in galaxies. The shock waves from these explosions can trigger the collapse of nearby gas clouds, giving rise to new generations of stars. In this way, supernovae contribute to the ongoing cycle of stellar birth and death that shapes the structure and evolution of galaxies. Studying supernovae also provides us with valuable insights into the fundamental laws of physics and the nature of the universe. By observing these distant events, we can learn about the properties of matter under extreme conditions and test our understanding of gravity and the expansion of the universe. In a very real sense, supernovae are cosmic laboratories, offering us a glimpse into the most extreme environments in the cosmos.